Georgie, what do you think of your first snow? Is it fun? Whoa! Is that so fun? So beautiful.
Hey, here to go.
Hey kiddos, let's look at number 1. Here we are going to show each expression on a number line and solve. So we are right now just working with numbers that have common or like denominators. Denominators again is the downstairs number, so 5 and 5, you guys all know that those are the same numbers. So we're just going to add 2/5 and 1/5 on a number line. Our interval here is going to be 5 because our denominator is 5. And this, just be very, very thoughtful when you are dividing your number line into intervals. We need 5 intervals. Not necessarily 5 lines, but we need 5 intervals because we're dividing the space between 0 and 1 into fifths. So I'm going to try to do this as evenly as possible. We'll see how it goes. So here's 1 interval. Here's 2, 3, 4, and 5. So let's make sure we're good. Okay, so we have 1, 2, 3, 4, and 5. We should have 5 equal intervals here. They're not exactly equal, but let's just use our imagination. So here we have 0/5, and then we have 1/5, 2/5, 3/5. Kendi was going to tell us that's 4/5. And another way to say 1 is 5/5. Okay, so now we're just going to use our jumping cursor to add 2/5 and 1/5. Okay, so we're starting with 1 2/5, okay, and then we're going to add a 1/5, and then we end up right here. So what we've just learned is that 2/5 plus 1/5 is equal to 3/5. Okay, cool. So that's not rocket science, but you guys, this is, I'm going to zoom out to clear that. This is going to really come in handy as we start working with more and more complex numbers. So let's just do one more here. We're going to show, this is not always so user-friendly. We're going to show each expression on the number line, and then we're going to solve. This one, D, actually is really interesting. So let's check D out. First, we're going to make our number line. Zip. And this number line, we'll start with 0. And let's look back at our problem and let's think about our intervals. The denominator is 4, so we need intervals of 4. So I'm going to go ahead and make, we're going to put hole number 1 here, and then we're going to put hole number 2 here. And the space in between each whole number needs to be divided into 4 hopefully equal chunks or 4 intervals. Keep in mind that doesn't mean that you're just going to mindlessly draw 4 lines. You need to divide each space between your whole numbers into 4 intervals. Let's see. So we have 1, 2, 3, 4 here, and then we have 1, 2, 3, 4 here. Just to keep you on your toes, in order to divide the space in between each whole number into 4 equal intervals, you're actually drawing 3 lines. So you have to really be mindful here. Okay, so this is 2 times 3/4 plus 1/4. Another way we could say this is 2 copies of 3/4 plus 1/4. Again, we're still working with like denominators. Life is not always going to be this sweet. Pretty soon, very soon actually, we're going to have unlike denominators, and we're going to have to do some work before we can even add them together or subtract them. So today, life is easy because these denominators are the same, which means these fractions are in the same language. So first, let's make 2 copies of 3/4. Okay, so first we're going to make a jump. We're going to start with 3/4. Okay, so we have 1/4, 2/4, 3/4. Okay, so that's 3/4. And then we're going to make a copy of that, meaning we're going to do it again. Okay, so we have 3/4, and now we're going to jump 1/4, 2/4, 3/4. This jump is 3/4. This mark, though, is not 3/4. What is it? Let's count how many fourths. Our stopping point. Let's see how many fourths we're at here. So we have 1/4, 2/4, 3/4, 4/4, 5/4, 6/4. Okay. So our stopping point here is 6/4, but we still need to add 1 more fourth. So we're going to jump, boop, 1 more fourth. We're going to end up at 7/4. Interesting. So we made 2 copies of 3/4. We landed at 6/4, and then we added 1 more fourth, and we arrived at 7/4. Here's the cool thing about 7/4. First of all, we consider 7/4 to be an improper fraction. I'm not labeling that point on the number line as 7/4. I'm just going to kind of break 7/4 down here. 7/4 is an improper fraction, meaning the top is larger than the bottom. 7/4, as you guys well know, went beyond 1 whole number. 7/4 is larger than 1 whole number. It's even pretty close to 2 whole numbers. We can, 7/4 we can rename as its whole number. How many whole numbers did we pass? 1. And then we have a fraction of a whole number as well. How many fourths is 7/4? Well, it's 1, 2, 3. We can rename 7/4 as 1 and 3/4. These 2 numbers represent the same amount. Fabulous. Kiddos, we're going to check out number 3 next. So in lesson 2, we are really exploring what it means to be an improper fraction. You guys know from 4th grade that when we have an improper fraction, the numerator here is larger than the denominator, which means that this fraction actually represents a number that is larger than 1 whole. Sometimes an improper fraction will represent a number that is larger than 2 wholes. So what we're going to do, and that's whole, W-H-O-L-E. So here in number 3, we're asked to express each of the following as the sum of a whole number and a fraction. We're going to be kind of breaking apart these improper fractions into the sum of a whole number and a fraction as to whatever is left over, and then show part C and D on a number line. We're going to take a look at B, so we'll put B on the number line. So here we have 9/2. We're going to rename 9/2 as 2/2. We're just going to decompose that 9. 2/2 plus 2/2 plus 2/2 plus 2/2. Okay, let's update ourselves. Where are we here? How many halves do we have? So we have 2, 4, 6, 8 halves. We're renaming 9/2. So we decomposed 9/2 into 2, 4, 6, 8 halves. And we have 1, thank you, Gabby, 1 half left over. Okay. So 9/2 is the same as 2/2 plus 2/2 plus 2/2 plus 2/2 plus 1/2. You guys are probably already thinking about the fact that we can now rename 2/2. Another way that we can think about 2/2, and let's just think about those squares that we were looking at yesterday. If I have 1 whole square and I divide it into 1 2/2, and we're shading both halves, how much shaded square do we have? Well, we have 2/2 of a shaded square. We also have 1 whole shaded square. Wow. So we can rename 2/2 as 1. We can rename 2 halves as, thank you, Eric, 1. We can rename 2 halves as, Tanner, 1, thank you. We can rename this 2 halves as, Alex, 1, beautiful. And we're just going to keep our 1 half as is because it's just such a beautiful fraction. Okay, so now we've renamed our 2 halves as 1. 2 half 1, 2 half 1, 2 half 1. Now let's rename 1 plus 1 plus 1 plus 1. Here is an excellent refresher from, I don't know, do you guys do this in kindergarten? 1 plus 1 plus 1 plus 1 is, thank you, Adve, is 4. So now we can rename 9 halves as 4 wholes plus 1 half. Interesting. Let's go ahead and show that on a number line to just beautifully represent this improper fraction. Okay, so here's our number line. Over here we will have 0. Over here, what number shall I have? We're trying to represent 9 halves, which we just renamed as 4 plus 1 half. What number should I put all the way over here, Kylie? Kylie just whispered 5, and Kylie, you would be correct. So this number line represents number 0 through 5. So we're going to mark our whole numbers. So we have 1, we have 2, we have 3, and we have 4. Wow, I think that is actually, those are pretty even intervals. I'm pretty proud of that work there. And then, you guys, our denominator, that number that lives downstairs, dictates how we are going to divide our intervals. Our denominator here is what? Ira, thank you. Ira is telling us, oh, Mrs. Calameres, our denominator is 2, so our intervals in between each whole number need to be 2. Keep in mind, again, friends, that doesn't mean that you're just going to mindlessly slap 2 lines in between each whole number. That means that you need to divide the space between your whole numbers into 2 equal pieces. If I just mindlessly slapped 2 lines in between 0 and 1, I would not have divided my space between 0 and 1 into 2 equal parts. So be very careful of that, you guys. That's pretty tricky. Okay, so now, because Ira was so helpful in telling us the denominator here is 2, I need to divide my space in between my whole numbers into 2 equal sections. Beautiful. So I have 1, 2 equal sections. And let's continue that work here. 1, 2 equal sections. Beautiful. And then between 3 and 4, we're going to divide that into 2 equal sections or into halves. And then in between my 4 and 5, we're going to divide that into 2 equal sections or into halves. Now what we're going to show is 9 halves on the number line. But we're going to show this version of 9 halves. Keep in mind, 4 plus 1 half is the same as 9 half. It represents the same amount. So we're going to start here, and we're going to take one giant leap to 4 whole numbers. So there's 1 whole number, 2, 3, and 4. Okay, so here we are at whole number 4. And now we need to add 1 half. So let's just do 1 jump to 1 half. And we've landed here at 4 and 1 half. You guys know another way we can express 4 and 1 half is 9 halves. That was so much fun.